once we have generated the required mesh, now what we need to do is we need to apply the boundary conditions. So in order to apply the boundary conditions, I am going to right click on the static structural, say insert, and I am going to go to remote displacement. And once I select the remote displacement, there are different scoping methods. From the scoping method, I am going to select, instead of geometric selection, I am going to select the remote point option, and there is only one remote point which I have created. So in the remote points, I can select only that particular point. I just click on the drop down arrow and I am going to select the same point which I have created earlier. So once I have done this, here it is asking me what are the components that are free and what are the components that are fixed. So here I am going to fix every component, so that the gear cannot translate, the gear cannot rotate. So once we have constrained all the required dimensions, now what I need to do is I need to provide a boundary condition for this particular rack so that it can slide up and down. So for that purpose, what I am going to do is I am going to say insert, and I am going to select the frictionless support, and I am going to select this particular edge, and I am going to apply the frictionless support. So what happens when I apply the frictionless support, this particular rack will not be moving in this direction, it can only move in this particular direction. So once I have done this thing, I need to apply the force. So for that purpose, I am going to right click on the static structural, say insert, and I am going to apply force. So once I select the force, I am going to select this particular edge and I am going to apply the force. So instead of the vector, I am going to change it to components, and in the components I am going to give 2500 newtons, because according to the problem, that is the force which has to be generated by this particular rack. So I have given 2500 newtons, and then I am going to solve. So I am going to right click and say solve. So once you have solved the problem, now what we need to do is we need to ask, or we need to view the results. For that purpose, what I am going to do is I am going to right click on the solution, say insert, and then I am going to see the total deformation, and I am going to right click, say evaluate all results. Now I am going to just see animate this particular results. In order to stop the animation, you can click here. In order to go forward to the next frame, you can click here. You can if you want to go to the previous frame, you can click here. You can set the speed of this particular animation through this settings. So here see, it is the rack is moving up and down in this particular fashion. This is because of the frictionless support that which I have provided to this edge. So then I am going to just stop the animation. Now what I need to do is I need to find out how much momentum has to be applied at this particular say at this particular surface to get a force of 2500 newtons at this face. For that purpose, what I am going to do is I am going to go to the solution. I am going to say insert. In the insert, I am going to go to the probe tool. In the probe tool, I am going to say I want momentum. So I want to select the moment reaction. And now once we have selected the moment reaction, we need to specify at which boundary condition we want this momentum to be calculated. So what happens, this is the surface, or this is the boundary conditions where we want the momentum to be calculated. That is why I am going to select this particular support, which is nothing but the remote displacement support. So I have selected this remote displacement support, and once I am satisfied with that, I am going to right click and say evaluate all results. So once I press evaluate all results, then you can see if I click on this moment reaction and just scroll down in the details window, then you can clearly see the value of momentum is 92,099 Newton mm. So our stated goal was to determine the required momentum that must be applied to the gear in order to produce a 2500 Newton force in the rack. And here from the computer we were able to calculate the required momentum to be 92,099 Newton mm. So the total approximate moment torque that is required was around 92,100 Newton mm. So now in the next case, what we are going to do is, instead of applying force here, we are going to apply this amount of torque here and then find out what is the force that is going to be generated at this particular face of the rack. Thank you.